He has been a pioneering voice in emphasizing the importance of land surface feedbacks such as soil moisture and urbanization. His efforts have helped strengthen partnerships, particularly with the Ministry of Earth Sciences. Today, Professor Niyogi will deliver an insightful talk titled Digital Earth Initiative, focusing on AI and digital twins. This talk draws inspiration from his discussions with Secretary Ministry of Earth Sciences. Professor Niyogi, it is an honor to have you with us today. The stage is yours. Thank you.
Thank you very much. I hope my slides are visible right now. Well, first of all, thank you very much for this incredible honor. It is truly an opportunity that I can not have even dreamt of, that the whole series of experts and the very organization, the Ministry of Earth Sciences, which has been a framework for continuing and engaging with the whole science community, earth science community. Uh, it is indeed a great honor to be celebrating its 19th Foundation Day, and I look forward to some conversation which I draw upon with the context of what I would hope would be the next 5 to 6 years as we look at perhaps going into the quarter century in the next 5 years, going from here. So, what I'm going to talk about is essentially a summary of work that has been going on with the context of a WCRP, the World Climate Research Program initiative on digital Earth lighthouse activity that I co-chair. There is also an UNESCO initiative that we have been developing on urban digital twins, and this whole notion of open data and how do we create the AI-based system that are at multiple scales? How do we try to build up a system that could be used for creating machine learning approaches for weather and climate, as well as digital twins that are at multiple scales, going from the city scale to the global scale. Perhaps the most famous example of the digital twin is right now the European Union's project Destination Earth, or the Destiny. And so I'm going to be talking a bit more on this whole summary that we have been setting up together. But I started off by saying that I'm so grateful that this is happening, even though the minister is not here, under his aegis, and also Secretary Ravichandran, who has been incredibly scholarly in his whole leadership into this whole initiative looking forward. I also, in this presentation, as well as in the context of some of the work that I'm going to be sharing, you will find that there are inputs and insights that have been drawn by many of the MOES leaders, both from the DG Meteorology, NCMRWF, IITM, as well as in COES. And it is a pleasure to acknowledge them in the context of the work that has been going on and what I'm going to be drawing on in some of the ways going forward. I will also be heavily drawing on in a US National Academy study that has been going on with the context of the future directions for digital twins. And one of my colleague, Karen Wilcox, she was the chair of that the study board, and we have been engaging with them through the WCRP initiative in terms of what we could do with regards to machine learning, and also acknowledge, of course, the Monsoon Mission and Mission MOSM and many of the initiatives that have come from there, which have contributed to the context here. So I want to go ahead with 7 takeaways that you can think of as we start thinking of this. First and foremost, India has become a $4 trillion GDP nation, and it is amongst the top 4 nations globally now in terms of its economic impact. And as we start looking at what is going to be that X factor where India can continue its economic rise or will have a pause, will be based on the weather and the hazards. So the more ability we have to manage our weather and hazards, our upward trend in the context of where we are going as an economic superpower is going to continue. That's number one. Number two, initiatives such as Mission Morsum are exceptional, powerful science infrastructure initiative that can continue India's growth as we try to see what is the framing of the leadership that is required for putting weather and earth science initiatives going forward. Third, there are HPC resources, the high performance computing resources that MOES has, which are among the top five global centers. Uh, and that's at 22 petaflops, as I understand. And there's a legitimate need and recommendation that this go up to 150 petaflops and perhaps that pre-exascale mode that is required for the next ushering the next era that we are going to have for high performance computing based improvements into our whole earth system framework. Fourth, earth science challenges in tropics and India in particular are very hard problems. They require continued fundamental discoveries, scientific achievements, measurements, modeling, and international cooperation, sort of the Sabka Saath, Sabka Vikas approach, which is both in not just within the context of India, but I would say in a global context as we are starting to look at the next 5 to 6 years in how we are going to try and achieve what we want to achieve with regards to this multi-scale discoveries and framework. Number five, the near future and in coming decades, it looks like AI and digital twin approaches are going to dominate forecasting and meteorological enterprise in a very big way. I don't know what is going to be its shelf life, whether it is going to be just for the next 5 to 10 years, whether it will take over by quantum, and this is just an intermediate period between in the manner in which we are going with a computing environment. But certainly, if I just look at it over the next 5 years, looks like AI and digital twins is where we have to start converging our efforts and start building a framework in how we are going to start approaching the path ahead. Number six, that the MOES's investments in earth science and AI models, this really needs strong subject matter experts and partnerships with national AI experts and initiatives that are forming. And there is one, for instance, there's a National Institute on AI being formed called NIRO, and partnerships such as that, where there are authentic AI experts, and then we have coming in as a domain experts. This kind of partnership and framework is clearly needed as we start looking into the future. Number seven, MOES continue its focus on fundamental research, investment in infrastructure, and build an ecosystem with broader partners, and create its own initiative, which I'm calling the MAIA, which is the MOES AI Initiative for Advances and Applications. And elements like what I heard about a Prithvi digital twins and local to global scales, etc. They can all come under this Maya initiative. But MOES needs to own an AI-based advances and applications initiative that is loosely in frame right now, as I see it from the framework. So these are our seven highlights that I would like you all to think about as we go forward in terms of where the nation stands, what is the X factor, there is a element of some mission. There is a need for HPC and a growth in HPC. There are hard challenges that we are working with the tropics. There is a potential for AI and digital twin framework, strong investments in terms of what MOES does with AI and digital twins, and in terms of the national experts, and its own initiative that it creates as an icon in terms of what is required from the earth science perspective. Now, with that, one of the big banner I want to highlight is this cannot be done at the cost of the investment in terms of the physics and dynamics based models, the measurements, and infrastructure growth, which is foundational in terms of whatever we need to do. And this should be sacrosanct and should never be touched. All the AI efforts, all the machine learning efforts are great, but at the core of it, we need to continue building up our physics, the dynamics, the physical chemical understanding into the processes that are going on forward. A few days back, I saw a interview that the honorable minister was giving, and he mentioned that he would like to see someone use this. That there is an IMD app, and the wife tells the husband, "You're walking out, and in 7 minutes it's going to start raining." I mean, this is the kind of framework where we want people to be going, that you're starting with a high level of accuracy in terms of where it is going to rain, when it is going to rain. This is the framework where we are going to start going with. And this comes into the shadow that just yesterday marked, I think, the 20th anniversary of the Mumbai heavy rain event. I think each of us who had experienced that kind of remembers where we were in Mumbai. It was one of those harrowing heavy rain events, which had incredible variability. North of Mumbai and south of Mumbai, we had almost like a month's rain coming up, a year's rain coming up in one part of the city, and just a normal rainfall in another part of the city. These kind of processes we know are very, very important localized phenomena that had been our challenges as we started looking into how do we deal with extreme events. And over the years, we have really developed a strong understanding that how do cities, how do the environment, how do the multiple scales interact, and we can start developing our understanding about what these systems do, how cities create their own convergence zone, how there is a zone where you can have a confluence of moisture fluxes, how this confluence of moisture fluxes can create a series of moisture bursts that can create these heavy rain scenarios by creating these micro convergence zones and so forth. And in process of doing so, we have not only understood what is happening over places like Mumbai, but in fact seen this happen globally and understood that there is not just a thing like an urban heat island, but there is something like an urban rainfall anomaly that exists globally. And we have to treat this small scale processes, especially in the tropics, very, very sophisticated manner way. Things like the soil moisture gradients, land use change gradients, the land sea gradients, even the micro SST gradients that that can exist off the coasts. All of that can have a framework by which a moisture pattern can start converging and create this heavy rain patterns for the city. Now, this we have known, and then it took us about 10 to 15 years to move that research to an operational setup where things are actually being put into practice. And this 10 to 15 years, by the way, is not unusual. This is what it takes right now, that you might have an idea in your computer, you might have an idea in your paper, and before it starts getting into operation, it takes almost 10 to 15 years before it can become operational at that point. And this is again not unusual for our field. This is something that is true across the board. Even in pharmaceutical or the drug discovery process, you might have a cure for a disease that we are trying to treat. And before that becomes available in the shelf where people can actually buy it and get treated, it takes 12 to 15 years. And it takes about 8,000 crores of investment before that idea becomes something which is part of a global landscape. So there is a lot of similarity between what happens with the drug discovery from concepts to something that comes to masses, as well as weather and earth sciences, where something that is coming from a concept to a masses that going forward. And the costs, of course, we do it very efficiently in earth sciences as compared to what happens in drug discovery. But the timeline is something that we should be aware. So the question that comes up is how do we speed up the disruption of what goes on in the context of research to operations in an MOES weather and climate services framework? And I speak in that context because that's what my expertise is. But I believe the context goes much broader into the ocean, into the earth sciences, and all other factors and technology that MOES has been a part of. I talked about the urban processes, and that's not the only example where this translation of science to operation is being on a pace. One other example is where we have the effect of soil moisture, which we call the brown ocean effect. We have known for almost now 15 years that if the land is wetter than normal, and if you have a tropical cyclone or a monsoon depression coming in, there's going to be a different inland penetration based on whether the soil is wet or dry. This we have known in many instances in the manner in which the heat fluxes, the entropy creation can have a feedback, and there are instances under which this can cause intensification or a stalling of a storm. We just had a very horrendous flooding event here in Texas where we had almost 250 people die. And one of the factors that people are thinking is that we had a strong drought that was going on, and we had a remnants of a storm, and the moisture that came in because of the dry conditions, that moisture was not being passed up, and it created a stalling of that system over the region where unfortunately those children were camping and several of them died in this rapid flash flood that occurred at night. So, this effect of what is a soil state and how it affects even the synoptic scale or a mesoscale processes is something we have understood. But really putting this into operations is where we are still waiting to go into that framework in terms of how we are going to have this feedback embedded in terms of storms, in terms of our depressions, and so forth. And we are all, of course, looking forward to the new NISAR data that is expected to come as it does its launch on the 30th of July. And we are all waiting for that long awaited output coming from the satellite products that will be coming from the soil moisture and other satellite products that will be coming. Now, as I said, this is not just about rainfall. It is not just about hazards. It is on, in fact, as we look into this $4 trillion economy that India has become, we are looking at all the cascade of hazards that we need to manage to continue the upward growth that India has. And that will be in the context of urban heat, landfalling cyclones, urban floods, and so on and so forth. So it is a very complicated problem with a lot at stake as we start going into the future. So the question again is, how do we speed up disruption or the research to operations in terms of the weather and climate services going forward? Now, many of you have probably heard this kind of a question that I hear from some visitors who come here or when I'm in India. And they ask this question that in US, I saw rainfall prediction being so accurate. Why am I not getting that in India? And this is a very incorrect question, but I wanted to highlight that because that comes at the core of some of the issue that we have. And the right answer here is that it is extremely hard in tropics to predict things like rain. It is true that it is not true that we are not getting good rainfall prediction in India. We are getting a very good rainfall prediction. It is with very high accuracy, but it is a hard problem because we are dealing with convection and not a frontal system. And so convection and not frontal system as in mid latitudes also means that the manner in which our nowcasting, the manner in which our predictions come up are going to be extremely locally dominated. It is based on the features like how you're going to get local anthropogenic sources, where you're going to get the sources of pollution, where you're going to get the dust factors, the topographical changes, and all these factors are extremely local scale and that require a localization and integration across the scales that is not necessarily always needed when we're trying to do a mid-latitudinal system going forward. Another way I again draw the analog in the drug discovery mode is that when you're treating a skin cancer versus a pancreatic cancer, both are very hard problems, but one is more treatable and other is more challenging than the other. They are still both very hard problems, but they are different kind of complexities involved. And when we are dealing with the tropical systems, we are dealing with an exceptionally complicated system. And this aspect, we need to convey a bit more to the general population that we do a great job. It is just that the problem is very, very hard, and we still do amazing in that part. If they're still a bit more mathematically inclined, I think what we should then discuss with them is the Heisenberg's uncertainty principle. And to just recap, we know that if you know the location well, we will have an uncertainty in timing. If you know the time well, then there is an uncertainty in the location, the very basic uncertainty principle. In the rainfall, the problem is even more complicated because here we are now required to be predicting five or six aspects precisely. Amount, how much is the rainfall going to be? Duration, how long is it going to be? Timing, when is it going to happen? Is it during the rush hours? Is it going to be at night time? The intensity, at what rate it is going to follow? Is it going to allow drainage or is it going to be a runoff? The location, is it going to be over a city? Is it going to over a forest area? Where in the city? And then in some instances, even the type of the rainfall, is it going to be snow, sleet, or a hail formation? And this is what we are expected to precisely predict every time. So this is a very hard problem. And we need to do a better job as a community to really educate the broader community that we are doing fabulous work. We are giving fabulous prediction for an extremely complicated system that is out there right now. Now, how can we then continue to improve, not just resting on the laurels that we have achieved where we are? And the first and foremost, I would say, is that a strong continued focus on studies to improve the fundamental understanding of the dynamics, physics, chemistry of the process at various scales. And I really applaud the mission MOSM on that context, how it is looking at it from the whole ecosystems. Second, I want to again highlight the role of measurements as a critical component and the first step of improving forecasts. Without monitoring and measurements in investment, we can never have strong initial conditions, and we know weather forecasting is an initial value problem. So we have to continue investing into our measurements to improve our forecasts. Third, the continued availability of high performance computing, such as what I've seen at IITM and other infrastructure investments based in radar, soil moisture, offshore platforms, automated weather stations. These are all critical assets that India should, and I'm really glad to know that they're going to continue building up more. And of course, needless to say, the humans are the most important resource for the continued improvement in the context of what we are going to be doing as an enterprise. Then, five, after the above four are satisfied, I think there is a clear need for a sustained, focused, prioritized investment and leadership in artificial intelligence across the board in MOES. This initiative, which I'm just colloquially calling as MAIA, that MOES AI initiative for advances and applications. And here I want to highlight that human intelligence, visioning, creativity, leadership is critical before we start getting into the artificial intelligence aspect of how do we effectively use it. So the human intelligence trumping or guiding the artificial intelligence going forward. And here's an example that I got from INCOIS about how the investments in science, HPC, and coupling and other factors really helps us. Here's an example of the INCOIS IOLA, the Indian Ocean Land Atmosphere atmospheric modeling system that INCOIS showed that if you put it with a coupled system with an ocean with a HICOM model, if you put it on a high performance computing system with a better model resolution, and if you do that coupling, that the uncertainty that you have or you had between the GFS track and the IMD best track really starts converging, and we start getting better predictions based on that system. So we know that better science, improved high performance computing, and improved understanding really leads to enhanced prediction skills. So this is a very positive thing to have. I'm also very glad to know of the massive investments that Mission MOSM is going to plan in terms of the observational network, the infrastructure that is going to set up, and the focus it is going to have across the board with regards to what it is going to do with regards to data sets, the benchmarking, and so forth. And going on with the aspects like what we have with the what I love to always look at the Har Ghar Mausam kind of approaches, bringing things down at a 5 kilometer scale, bringing it down at a very local scale, and improving our weather forecasting at a much, much more impact driven perspective in coming decade. These are very aspirational goals. These are great goals, and these are something we can all stand behind. Where you're going to work with the AI machine learning approaches, you're going to work with forecasters, and these two are going to be one of the tools that are going to talk to each other. And this is where the vision is going with regards to the future of forecasting, not just for the India Met Department, but many of the forecasting centers across the globe right now, the integration of AI, machine learning, the human expertise, and the computational technology that goes in. Much of what I've been learning and speaking has been based on a series of digital twin workshops that we have been leading, working with the WCRP and UNESCO in the last 2 years or so, where we have been bringing in National Academy experts, we have been bringing global experts, and trying to put together a framework of how do we now go where we have multi-scale problems, and there are many factors in a model, in an Earth system model, that we cannot represent. It could be things like the local mobility of vehicles that can create pollution, or it could be policy which can, the can create some of the local factors that we have not have an ability to put into Earth system model. So all of these factors we have now been able to put together into this umbrella of a digital twin. And this digital twin is not just a model with some more bells and whistles. It is really those things that we have had physics constraints, dynamical constraints, to be able to go across the scale without violating some of the basic assumptions that we have, and then try and put this into a framework that can become a seamless way to move across the scales from global to meso to micro to even at an community scale in terms of doing. And I'll show you some of the examples about how the digital twins are paving the path of where the community is going, not just at the global fast models, but even in terms of the impact based assessments that are required at a very local scale. And it starts by bringing in data. It starts by focusing on some of the decisions that are required by the community, whether it is the heat stress management, whether it is in terms of the energy management, whether it is a hydropower decision, or whether it is in terms of, flooding and other factors. And then there is the whole impact of the identifying which parts of the community you have a critical infrastructure that you need to be predicting for, and they try to save those critical infrastructure in terms of our and output and so forth. So we have had a series of workshops that have been going on from the context of power infrastructure, in terms of coastal digital twins, in terms of what we'll have for urban infrastructure design, in terms of the open environment, the visualization, the global scale analysis. And there is, in fact, a third one that will be coming up on August 7th and 8th, which is going to be with the European partners. And I invite my colleagues from India to also please join in if there is interest in terms of what we'll be doing for the digital twin framework. Now, this comes up in the context of where we have a data, sensors, models, all tying in together. And this is a very cell phone based delivery mode, which is very localized in terms of delivering that information. That is the ultimate goal when you're trying to go with a digital twin that is slightly different than a model. A model will give you an output, a digital twin will give you information, an information that is guiding your decision, a decision that is required in terms of something that you're going to then act upon. And so there is an inherent component of a stakeholder, a decision, and a scale that is embedded within that model framework as we start looking at where do we start going into the next generation's models and studies, where we have now AI integrating with the physics-based models going forth. So when you start thinking about how is AI right now being used in most of our earth science models, there are four different ways this is being done. First and foremost is in what we call data driven approaches. You have a lot of data, and based on that, you're trying to find out a way that you can improve a certain part of a model system. Typically, for instance, this has been done for air quality. You have a lot of air quality data. You're going to be using a simple model. Previously, people used something like an AR2 and ARIMA model or some statistical model. And now you're using a bit more sophisticated deep learning techniques to predict what is going to be the ozone level, particulate levels, and so forth. We have always used things like the surface temperature, sea surface temperature, and El Nino assessments. We have used EOF or other kind of analysis. Now we can use a bit more of a sophisticated manners, data sets that can be tagged into this whole analysis. That's our data driven approach, where you have a lot of data and you're just running it through different techniques that are now becoming available. A second approach is through parameterizations. Each of our model has huge parameterizations, which take a lot of time. Cloud computing, or the cloud computational models, or in terms of the evaporation models, or the manner in which you're doing energy computations. Each of that, instead of going through a physics module, it can go through a simplified model. And that's where you're coming up with an improved parameterization that is part of a bigger modeling system. That is the embedded hybrid approach that people are using with AI within a part of a physics-based model. A third way is in the downscaling approaches, where you have an output from a coarser model, and then you're using the vision approaches that people use in image analysis from vision technology or graphics technology. And then you are developing what is known as a convolution approach, where you create a fine resolution image using signal processing techniques and then ask the question, what data would have created that fine resolution technique, and then you back calculate that data. That is a downscaling approach, which is very different than the statistical or a dynamical downscaling that we have done in weather and climate models, where we had to run a model with a higher resolution. Here you are just taking an image, running it through signal processing algorithms, creating a finer resolution image, and from that finer resolution image, you're creating finer resolution data. So that's another way people have been now using AI-based approaches for the data sets going forward. And the last approaches is in terms of causal patterns. And this causal patterns comes in two forms. One is where we have our traditional thinking that if it's an El Nino, if it's a La Nina, we can then start seeing the linkages in terms of temperature or rainfall onset and so forth. So that's a very physical causal approach that is used. And a second causal approach is in terms of the large language models, where you know what are kind of answers that can be expected for the kind of questions that come up. And you have this whole learning mechanism on the basis of which you can start putting this basis of responses that can start coming together through the use of large language models in terms of the output that gets from this model. So these are these four basic ways by which AI has been embedded into our Earth system applications by looking at data, improving model parameterizations, by downscaling or upscaling, and then look at causality into the frame that goes forward. Here's an example of that. We are all running models at a very high resolution, and we need something as a building data. It is almost impossible to get building data across the globe with a precision that we want to put it into a 5 kilometer model or a 5 meter model. Because even if you do a LiDAR survey, that is going to be changing after a year, and then you might have new construction and so forth. So you can, however, use deep learning techniques with some of these satellite data sets, and we have shown that you can create global data sets with regards to building height and factors such as like that, which are very, very hard to get otherwise. So this is an example of improving parameterizations by looking at data set. Then you can use that data into model simulations by improving some of the parameterization pathways that go forth. You can show that this can have a feedback into the parameterization with the dynamics, and this can have an impact on things like thermal comfort and so forth that I'll show for the project that India Met Department is doing, IMD is doing right now with Delhi and so forth. We tested these approaches for places like testing it against the traditional physics-based models as part of the WWRP research demonstration project, where you can run the AI-based models, and in parallel, you have all the operational centers running their own physics-based models. And these are all blind tests. In the morning, we are doing a forecast, and everyone is comparing the results with the observations that we get and trying to see how these models compare in terms of the physics, in terms of the AI, and so forth. And generally, these AI models, which are relatively fast, are doing a fairly robust job. There is a lot of uncertainty at times, but they're still doing a good job. They're also giving us parameters which are very hard to predict in traditional models, things like a thermal comfort, which is at 2 meter resolution, 2 meter by 2 meter resolution. You can't run a weather forecast model at 2 meter by 2 meter resolution at this point unless you're doing a computational fluid dynamic kind of approach. And this is being done in a dynamic way on a day-to-day basis. And you can start creating a series of very high resolution imagery, which otherwise is not possible. It is almost looking like a video game in terms of creating the whole environment of the data sets that can be ingested into the model, the kind of information you can bring down at a very local scale, whether it is shaded, unshaded, whether you're into a canyon where you can have winds, or in locations where it is going to be away from certain location, and so on and so forth. So this kind of information you can start pulling together in the context of the digital twins, where you're looking at a global models, regional models, and then going down to very local scale models. So, with the efforts that are going on at IMD, for instance, there is an work going on in downscaling the rainfall data sets at a city scale by looking at all the building heights, street canyon, and so on other information. And you can then start seeing which kind of algorithms, downscaling algorithm, can give you some really good results into the setup. there is a thermal heat mapping algorithm that is being used right now that is creating for Delhi an experimental 2 meter data set that is providing very high resolution data set that is being still tested, but IMD should be able to provide this very soon, is my understanding, in terms of what is the thermal maps and how it will have the thermal heat comfort and so forth. So this is still in the experimental stage, but locations of what you could have between, say, the Connaught Circle to other places that you might see, where you might have the high heat stress and low heat stress conditions, and that can become a very localized forecast for heat stress across the city going forward. We have also created from AI based models a reanalysis, which is a 45-year reanalysis globally that is available in terms of the global 12-hour runs for every quarter degree at every 15 day. For every 6 hours we have a 15-day forecast that is going forward into the output, and these data are available, and we are hoping that this could be also hosted at the MOES data center at some point in terms of the terabytes of data that we would have. Now, there are several other things going on at MOES which are based on the AI machine learning bricks framework. This is something from NCMR where they are trying different models like GraphCast, ForecastNet, Pangu Weather, all providing different conditions in the manner in which AI and machine learning based approaches can be used to study things like the progress of monsoon. It can be used in the context of also a large language model for developing guidance on a specific forecast, where I believe they're calling it the AI weather expert, in terms of providing a specific imagery, asking information to provide some framework. And remember the causality I mentioned about, where you can start getting some detailed output spit out by the model into the large language model in terms of the impact and so forth. Similarly, at IITM, I hear there's a MOSM GPT going on where you have a link between the Earth system models and applications and a link between large language models. And then that can also interface as a part of the Prithvi AI or the Prithvi Pratibim that is being put together with regards to what you can do with a digital twin, where you have a physics informed models and where you can have a data and AI plus the machine learning frameworks all pulling together and then going in terms of a massive quadri of things of where you're doing data crunching, you're getting some information out of it, interfacing across layers and doing it in a rather fast manner, trying to develop this analysis, like you can see into this vector diagram in terms of where you could have the whole voice to text to voice interface of an output and so forth. So these efforts are not just conceptual. These are going on right now in some form or the other, in some nascent way or another, where you're trying to use it for a specific application across the MOES organizations in terms of what it could be doing. The impact or the scale might be from a small scale application to a near operational stage, but they're really underway. And I'm very pleased to also see the manner in which there is a massive growth in the high performance computing infrastructure that is actually supporting this infrastructure. It is sort of like you want to get into a race, but you have a 1960s car which can't have a speed more than 60 kilometers per hour. You can't get into a race. I think in this scenario, we have a car which is going to be at a turbo speed. It is going to be at a very high space. We are going to have high degree of petaflops available, and there seems to be a plan to increase that HPC going forward. So all of this is fantastic news in terms of what MOES can do going forward into the future. It's not just weather. I got this particular one from Incois, where I believe they have this HIFA, where you are using a deep network, a deep learning based approach for finding out where you can have the hilsa fish, and that can be used by the fishermen in terms of where you could have some output with regards to where you should be fishing and so forth. So the applications of what you could do with regards to a stakeholder. And this is an example actually of a digital twin, I would say, where there is a specific case where there is a stakeholder, there is a specific application, and then there's a downscale of a forecast that is being used in creating the output. So the applications are multifold. And if you look across the MOES, you can see a range of things that are going on right now, from data sets, from analysis to setup of what is being done with digital twins and so forth. So it comes to two last things before I close up. And the first is, what is the difference between the AI models or the and the regular models? A big part of the digital twins is that there is a need for an end user. There is a big part of machine learning. There is a big part of visualization that needs to come up, and there's a massive speed. They're almost 1000x times faster than typical models, so you can do a lot of runs. But a lot of runs also mean a lot of data that is going to be generated, and there is a data ecosystem that will start coming up. And there are going to be issues of ethics of data and so forth. I'll come back in a bit. So, in conclusion, I would like to say that MOES has made an incredible head start, and there is a need for AI and uh, digital twin initiatives that are going forward. But how do you go forward? I think there are five things I learned from my mother, and I always want to say that I can use it for the AI models. The first is do good work and train hard. The same way, I think MOES has capability and a need for observations and baseline data for creating the benchmark and training models. There is now a tendency that you'll find paper after paper after paper saying that we have used an AI based model or a machine based model and we are doing great work. There is a real need for an authentic baseline to be created, a training data set and a baseline to be created. That unless a model can achieve that benchmark, it should not be used. So creating that benchmark is one of the first thing that MOES ought to be doing. Second, serve. That is focus on applications. It is one thing to create these foundational models, and they are really important. But as these models are being created, it is really important that we start creating this very localized, stakeholder driven applications that are creating these digital twins out of those foundation models. Third is do good. And by that, we mean how do we build ethical choices? What is going to be the guidance to a forecaster when an AI system says one thing and when a physics based model says another thing? Which one are you going to use and provide as a guidance? How are you going to look for that uncertainty and explainability that comes from an AI system, which you cannot understand, versus a physics system, which you can understand, but will have a high uncertainty? How are we going to train the forecasters, or how are we going to train the community on this ethics of the use of the data? Fourth is what my mother always said, be yourself and you don't need to copy others. In the same way, I think MOES needs to create its own foundation model. It is on the track. I highly recommend that MOES try its own AI based initiative on applications and advances. There is a tremendous strength of data sets, localized problems, and applications that can become a benchmark for the rest of the world. And as it creates its own digital twins and AI environment. And I would say fifth is what I've learned to share and enjoy. That this is the kind of ecosystem where you cannot have the models and hold on to yourself. The more we collaborate in the AI space, the more we are going to learn and win. And so there is going to be requiring a whole new open knowledge framework as to where we are going to be very open with the data, open with models, and building up the models, and yet retaining the authenticity and the official capacity of forecasts and use and in the manner in which the data sets are going to be used. So the problems and challenges are hard. MOES definitely needs to strategically partner with national investments that are going on where we have the MOES subject experts, but we need to get the AI domain experts that are coming from a national initiative. So a partnership with some of those national initiatives is a very big one. And again, I close by saying this cannot be at the cost of fundamental and physics dynamics based model development and understanding. This should be sacrosanct. AI is good. AI is the flavor of the year. It is probably the flavor of the decade. But fundamental understanding, foundational knowledge is always going to be foundational. And only then we can make real advances going forward. So, with that, I thank you very much for the opportunity and I look forward to be educated. Thank you.
Thank you, Professor Neogi, for sharing visionary insights on the challenges and sorry, for your insights on the challenges and way forward for AI and digital twin for MOES. Sir, please be with us online because we are waiting for Honorable Minister to join us, and we're told he'll be here soon. Thank you so much, sir. Thank you.
I think we are expecting Honorable Minister very soon. And Professor Dev has completed his lecture. But I think whatever time we have in between, if somebody has any comment or any question to Professor Dev, I think I will request maybe people from IMD and CMRDA, if you have any question, you can have any comment like what type of cooperative or you are doing work with Dr. Dev. If you have any questions. Somebody should give them mic. Yeah, I will.
So thank you. I, at the outset, congratulate Professor Dev for an excellent lecture with very futuristic proposals for Minister of Earth Sciences. Actually, you have put up before us the way forward for each and every institution under Ministry of Earth Sciences. I have a certain few queries. For example, at present, people are also working like ECMWF about a model based on simple observations. So there are various scopes. What is the scope to go further in Ministry of Earth Sciences?
Namaskar and good afternoon to everyone present here, and a warm welcome to those joining us virtually from across the country. In a world shaped increasingly by climate change and natural disasters, the Ministry of Earth Sciences stands as a beacon of scientific excellence and national resilience. From its humble beginnings as the Department of Ocean Development in 1981 to its elevation as a full-fledged ministry in 2006, we have consistently pushed the frontiers of Earth system science. Today, as we celebrate the 19th Foundation Day of the Ministry, we are not merely marking another milestone. We are reaffirming our collective commitment to scientific advancement, national resilience, and a pursuit of a sustainable future for all. We are deeply honored to have with us today Honorable Dr. Jitendra Singh, Minister of State, Independent Charge for Science and Technology and Earth Sciences, Minister of State, Prime Minister's Office, Ministry of Personnel, Public Grievances and Pension, Department of Atomic Energy, and Department of Space. Dr. M. Ravichandran, Secretary, Ministry of Earth Sciences, Sri D. Senthil Pandian, Joint Secretary, Ministry of Earth Sciences, Dr. M. Mohapatra, Director General of Meteorology, India Meteorological Department, Dr. Vijay Kumar, Scientist G and Program Head, Ministry of Earth Sciences. We also take this opportunity to welcome our guest of honor, Professor Dev Niyogi, who just delivered the popular talk. I take this opportunity to also welcome the distinguished scientists, guests, colleagues, and members of the scientific community. A special welcome and heartfelt gratitude to the secretaries, former secretaries whose vision and leadership has shaped this ministry's journey, who has joined us virtually. I now request Secretary MOES to welcome Honorable Minister with a shawl and a bouquet. We also request Secretary MOES to present a sample of the polymetallic nodule collected from the Indian Ocean Contracted Region for India to the Honorable Minister. Thank you, sir, for joining us today. To formally commence today's program, I now invite Sri D. Senthil Pandian, Joint Secretary, Ministry of Earth Sciences, to deliver the welcome address.
Good afternoon to you all. Chief guest of this Foundation Day celebrations, Honorable Minister of Earth Sciences, Dr. Jitendra Singh Ji, Secretary MOES, Dr. Ravichandran Ji, Guest of Honor, Professor Dev Niyogi Ji, UNESCO Chair on AI, Water and Cities at the University of Texas, DGM IMD, Dr. Mahapatra Ji, Senior Scientist, Dr. Vijay Kumar Ji, Head of the institutions, former secretaries, distinguished scientists, dedicated staffs associated with the ministry, representatives from printing and electronic media, ladies and gentlemen, on behalf of the Ministry of Earth Sciences, I extend a warm welcome to all of you on this auspicious occasion of the Foundation Day of the Ministry of Earth Sciences. Today, we gather here to celebrate the milestone achieved over the years and to look forward to a future filled with innovation and sustainable development. The Ministry of Earth Sciences has significantly enhanced our scientific understanding of the environment through its institutes in meteorology, oceanography, seismology, and polar sciences, enabling evidence-based policies and decision-making that improve our ability to predict and mitigate natural disasters while safeguarding lives and properties. Moreover, the ministry's contribution extend beyond the boundaries of India. In collaboration with the global scientific community, it has actively participated in numerous international projects and initiatives, reinforcing India's position as a formidable player in the field of earth sciences. I would like to take this opportunity to commend the scientists, researchers, and dedicated staffs associated with the ministry for their unwavering commitment and contributions to the field of earth sciences. I would also like to express gratitude to the Honorable Minister for the continued support and encouragement in fostering scientific advancements. Thank you all for being here to celebrate this significant milestone. Jai Hind. Thank you.
Thank you, sir. Dr. M. Ravichandran, Secretary, Ministry of Earth Sciences, is a visionary oceanographer who has served with distinction
Respected Honorable Minister, Dr. Jitendra Singh, Director General of Meteorology, Dr. Mohapatra, Sri Senthil Pandian, Joint Secretary, Ministry of Earth Sciences, Dr. Vijay Kumar, Advisors, Professor Dev Niyogi, Department of Earth and Planetary Sciences, Jackson School of Geosciences, University of Texas at Austin, directors of various institutions of MOES, especially Tamban, Chalpati Rao, Bala, Surya, Kankara, Mishra, Prasad, and Mahesh, and other colleagues and friends from ministry, and invitees and former secretaries in the online, and directors, those who are in online. Very good morning to all of you. Indeed, it's a great pleasure to be here on this particular year where we are celebrating a 19th year of Foundation Day of Ministry of Earth Sciences. I think we are transitioned from adolescence to adulthood. That means youth to maturity. And first and foremost, I thank you all for coming as well as your contribution to the Ministry of Earth Sciences for the nation building. I look forward, continues your contribution. I look forward your research as well as science to services for the benefit of society. Thank you one and all for your immense contributions. In the last 1 year, I think we have a significant contributions we have done for the national growth. Of course, we have celebrated 150 years of IMD, and also we have, very importantly, we have got the important project. It is a mission MOES, actually, where we want to improve our weather forecast in establishing various infrastructures. And there are many activities, of course, we have achievements we have done. I don't want to list it because of want of time. But main thing is, I want to just highlight the Bharat forecast system and Mumbai urban radar network and IITM, that decadal prediction. Of course, NCMRWF has come out with very innovative approaches, and 30 years of NWP. Now they are migrating from NWP to AI-based, and especially they are going for a large language model. Very impressive results they brought out. And also they are catering to various sectors, power sector and agri and other sectors. They are contributing continuously. And as far as the ocean sector is concerned, NIOT, the ambitious mission of our ministry is Samudrayan. It is already, west test already has completed in trials and everything as harbor we have done. So we are looking forward in the 1 year time frame. We are planning to go for dive soon. And also we have made a lot of tests with the manned as well as unmanned dives in the ocean in the Chennai harbor. And also acoustic telephone has been also what is called, we have tested. Now it is ready for communication within the ocean. And also they have made a lot of LTTD plant, that means desalination plant in the in Lakshadweep Island. And also acoustic lab has been inaugurated. And there are many things has been done by NIOT, especially submersible fish cage in Andaman. And there are about many trials in Andaman trials, sea mining. Of course, one of the nodal has been collected from Andaman Sea, where we are able to collect from our own mining machine. And INCAIS also has done a lot of effort in terms of coastal vulnerability map, 1:25,000 scale. And observing system have been augmented significantly in the ocean observations in terms of gliders and Argos. And also they have come out with the mini atlas, ocean energy atlas, how much energy from each state in the coastal state, how much energy is available in terms of ocean. They have brought out very atlas. And also CMLR has come out with more than 1,000 deep sea biodiversity samples. I understand that last maybe 5 to 10 years, we have 50 new species and 100 new records have brought out. And we have already signed a BBNJ agreement. That means it is basically biodiversity beyond national jurisdiction that we have signed. Now we are about to ratify that one soon. And also NCCR has made a lot of shoreline management plan, which has been given to the state government of various state government in the coastal state. And Vizag, they have made a new center at Vizag. And NCPR, of course, they have gone into Pan-Arctic approach, various, apart from Svalbard, they have gone to Canadian Arctic, then again Greenland and many places. They have ventured into Pan-Arctic approach. And also new research vessel we are going on, building, it is going on. And there are very important discovery has been done jointly by NCPOR as well as NIOT. Active, inactive vent of hydrothermal vents have been identified in the Indian Ocean. It is a breakthrough achievements. And also NCS has made many improvement in the last 1 year, especially installing various seismometers all around India. And also we are going to plan BGRL. Of course, we need to have a more augmentation of BGRL, especially make a new autonomous attached office of BGRL so that it can grow much further. There are many things are there because in future also we need to do more. I have list of things which I will share you independently because I don't have time to explain all the things because of short of time. And once again, I thank you for your contribution. I look forward continue your contribution for the growth journey of Ministry of Earth Sciences as well as for the country as a whole. Thank you very much.
Thank you, sir. We now move on to the official launch of scientific initiatives and research outputs from the premier institutions of MOES. We start with IMD. The first release is the Block-Wise Rainfall Monitoring Scheme, BRMS, developed by IMD.
India Meteorological Department is nodal agency for providing rainfall statistics for the country, state, meteorological subdivision, and district. Launched in 1992, IMD currently uses district-wise rainfall monitoring scheme for real-time monitoring, collection, and analysis of rainfall data. Starting with 2,000 rain gauge stations in 1992, and IMD utilizes more than 6,700 rain gauges across the country today to provide daily, monthly, seasonal, annual, and rainfall statistics. Rainfall statistics are now calculated for 738 districts. With the launch of indigenously developed block-wise rainfall monitoring scheme, IMD will provide the block-level statistics for 7,200 blocks. This will be a 10-fold increase in the spatial rainfall resolution of daily data provided to various stakeholders. The block-wise rainfall monitoring scheme, BRMS, will...
Next, we have the launch of the district-wise crop weather calendar.
District-wise crop weather calendar, a step towards resilient agriculture. Weather plays a crucial role across the different stages of crops, influencing input costs, agricultural practices, and ultimately yield. The crop weather calendar, CWC, which integrates the stage-wise information on weather parameters like temperature, rainfall, humidity, wind, and evapotranspiration, serve as a tool in guiding timely agricultural operations, irrigation scheduling, optimizing resource, and implementing weather-based crop management strategies. To address these requirements, the district-wise CWC has been developed by IMD, Ministry of Earth Sciences, in collaboration with ICR, state and central agricultural universities, and state agriculture departments under GKM.
IMD has also developed India's first ensemble-based high-resolution rainfall dataset. Please, sir.
Indian Precipitation Ensemble Dataset (IPAD) is India's first observation-based ensemble rainfall dataset at a resolution of about 10 kilometers compared to existing 25 kilometers resolution. It has been jointly developed by Climate Research and Services, IMD Pune, and the Hydroscience Lab at IIT Delhi. It combines IMD's dense rain gauge network with terrenated interpolation.
The Indian Institute of Tropical Meteorology, IITM Pune, has developed the next generation extended range weather prediction model named the Bharat FS ERP.
विस्तारित अवधि पूर्वानुमान प्रारंभिक योजना और प्रतिकूल मौसम प्रभावों की रोकथाम के लिए आवश्यक हैं। पृथ्वी विज्ञान मंत्रालय
Dr. Suresh Chandra Rao, Director IITM, to kindly hand over the Bharat FS ERP to Dr. M. Mahapatra, DGM IMD, for operational purposes in the presence of Honorable Minister. Thank you, sir. IITM has also developed the AQEWS. It is a new air quality forecasting system developed by IMD. We have a video on it.
New Delhi, India's capital, has been battling with air pollution every autumn and winter for over a decade, owing to the conducive meteorological
Dr. Suresh
conditions
Chandra Rao,
and
Director
anthropogenic
IITM,
emissions.
has handed
While
over
the
the
existing
airways
air
to
quality
Dr.
early warnings
Mahapatra for operational use. Thank you. We now have the National Institute of Ocean Technology, Chennai, who has prepared a comprehensive wave atlas for the northern Indian Ocean. This updated version offers 30 years of detailed wave data for 50 locations across India's territorial waters, including the Lakshadweep, the Andaman, and the Nicobar Islands. Sir, I request you to do the honor. The video. Yeah, it's a curtain raiser. Thank you. Thank you. To harness the full potential of India's 11,000-kilometer coastline and vast exclusive economic zone, the ministry launched a national initiative to map the seafloor. As part of this effort, an IoT has developed a high-resolution bathymetric charts for East Coast covering depths 0 to 30 meters. These charts will be vital for coastal development and marine engineering. May I now request Honorable Minister to release the seabed charts virtually. Sir. Thank you, sir. The Center for Marine Living Resources and Ecology has prepared a compendium of new marine faunal discoveries from 2012 to 2024, documenting significant species found in the Indian EEZ and high seas. We will now play a short video introducing this important work. May I request Dr. Ravi Kumar, Head CMLRE, to kindly join us on stage for the release of the report. CMLRE has also prepared building a baseline publication detailing standardized methods for surveying, preserving, and documenting marine biodiversity. So kindly do the honors. The National Center for Seismology is at the forefront of earthquake science and seismic assessment in India. Today they present the seismic microzonation reports for 4 cities, Bhubaneswar, Chennai, Coimbatore and Mangalore. These reports provide detailed seismic hazard assessments that will guide resilient infrastructure design and disaster preparedness. May I request Dr. O.P. Mishra, Director NCS, and Jagveer Singh Ji, Head NCS, to come up on stage. Request Honorable Minister to please do the honors. Thank you, sir. We have a documentary film on the life-saving impact of India Meteorological Department. We request Honorable Minister to please release the video. Sir. Video. Honorable Minister, there's a video. Life-saving impact of IMD. We'll be releasing it on all social media platforms. Thank you. We will be releasing the video on all our social media platforms. We congratulate all contributing institutions and scientists who have involved in these remarkable developments. It is my distinguished honor to introduce Dr. Jitendra Singh, Honorable Minister of State, Independent Charge for Science and Technology and Earth Sciences. He is also the Minister of State in the PMO, the Ministry of Personnel, Public Grievances and Pensions, Department of Atomic Energy and Space. Sir, please join me in addressing Dr. Jitendra Singh.
Thank you. I thought you would be making 19 releases, but you fell short of somewhere, I think 10 or 11? Yeah, 14. Yeah, but you could have thought of having 5 more, so you could be, synchronizing with the birth celebrations. Secretary Earth Sciences, Dr. Ravi Chandran, Dr. Mahapatra, Mr. Pandian, Dr. Vijay, the members of the faculty, ladies and gentlemen. At the outset, I have to perform the pleasant task of formally congratulating you all on the 19th Foundation Day of the Ministry of Earth Sciences. And as was being pointed out by Dr. Ravi Chandran, in other words, this is also going to be the last year of the teenage. So you can realize what all you are going to miss and what are you going to earn in bargain of that. And youth, as it comes with both its challenges as well as opportunities, and which of course sometimes is so closely intertwined that it becomes difficult to figure out whether what we confront is a challenge or an opportunity. But that precisely makes it exciting. And as you've seen, it's been a remarkable journey over these last 19 years. And as Dr. Ravi Chandran pointed out, the last few years has been really remarkable in the sense that the Ministry of Earth Sciences has gained wide recognition, wide visibility. In fact, when Dr. Ravi Chandran newly came into this ministry, I told him you have to do something to undo the popular impression. And then I said, if you do a survey, a roadside survey in Delhi asking people where on earth is the office of the Ministry of Earth Sciences, I'm sure very few will be able to answer that. But now it's not only gained acceptability, acknowledgement, recognition, but it's also being sought after, not only within country, outside country. And I'm glad that the Secretary of Earth Sciences now is sought after even by the international bodies, and so also the Director General, IMD. And this has been possible because of the tremendous amount of hard work and tremendous amount of consistent effort that has gone behind this. But most of all, also because of the last 10 years, or to be precise, 11 years, we have had a very supportive government in place. Because we had all the talent even earlier, but possibly we didn't have the kind of enabling support from the policy makers, from the political dispensation, which is coming forth. And since we are sitting in a galaxy of scientists, so we don't talk without evidence, I know how many of you have realized that something like Deep Ocean Mission was announced by Prime Minister from the ramparts of Red Fort in his Independence Day address, not once but twice consecutively in 2022 and 2023. Normally, Prime Ministers are not known to pick up such scientifically loaded subjects, which do not actually percolate across the sections. But possibly, the feeling behind that, the sentiment behind that, the intention behind that was that what Prime Minister says is taken seriously, also pondered over seriously, also analyzed seriously, so that the message could go across to the country when they look here. Now when we are going to add value to our economic growth, it is the blue economy which is going to be explored, which had not been explored earlier. And therefore lies the importance of Deep Ocean Mission. And then again, as it was mentioned by Secretary, the mission MOES was launched by Prime Minister himself. So I think when things start happening at the highest level, those working down the ladder spontaneously also tend to get recognized, accepted, identified. So I think that's a big change which has happened over the last 1 decade. And the support has been forthcoming in every aspect, financially, technically. For example, in Doppler weather radars, Dr. Mahapatra would be complimentary to know that we have moved from 15 to 41, more than double in just 10, 11 years. Our seismic stations, our weather stations, our upper air observations, our rain gauges have more than doubled in the last 10 years. Our earthquake tremors, now we have, within 2 minutes we are able to, of course there's no forecast for an earthquake anywhere in the world, but soon after the earthquake at least you can send out an alert so that the people are careful or watchful about a subsequent tremor. And that started happening just in 1 or 2 minutes. In fact, the best example of this is that a few months back when there was an earthquake in Delhi, the website got choked. So many of people trying to reach out. The website got choked within just about 2.5 minutes, and within 5 minutes, it was news all over the social media, television, what happened to the website. So they were actually finding fault with the ministry that the website was not functioning. So we had to actually explain to them that you had accessed in such heavy load which was not expected, and therefore it's got blocked or choked. And thereafter, of course, the ministry also decided that we would upgrade the portal or the website. So that is the kind of the reach out, the kind of credibility, trustworthiness of this ministry which has developed over the years. And now we are also into underwater robots for earthquakes, cyclone alerts, as he was mentioning one of those films. Dr. Mahapatra is very keen to take care of that because he's gone through one of the worst cyclones that this South Asia ever saw, because his land went through that super cyclone 1999, where 10,000 people got killed simply because there was not much of a forecast facility. And ever since Mahapatra has taken over, there has not been a single such episode in his state of Odisha. So I think you can also go back and say that pride, you are paid back to your motherland in the best possible way you could do, in the best possible expertise that you had. And it's been possible, not that the cyclones have stopped happening. In fact, they are happening now even a larger measure and more frequency because of the environmental changes. But our mitigation and disaster management and forecast facility and capability has tremendously improved. Similarly, you're also contributing to the other sectorial issues, like, for example, the agri sector. Much was shown in these films also. We have a very progressive agri ecosystem, in fact. The other day, I was also discussing with the officers in the agriculture sector. IMD and the Ministry of Earth Sciences is playing a very vital, though relatively underplayed, underrated role in the success stories of many of the agri initiatives, which would not have been possible if you didn't provide them support. You have Make Doot app, for example, with more than 7 lakh farmers. The problem is that the awareness is not enough. The other day also, one of the media persons, I think one of the press conferences where many of us were there, she said there's hardly any forecast for the farmers available. And that's because, unfortunately, we had not succeeded in making her aware of something like Make Doot app or something like the SMS advisories, which are available for the farmers, for the fishery. So I think we need to also tone up our social media handles and try to reach out to the people in the language they know the best or they understand the best. Most of them do not even access newspapers or the news bulletins. So I'm sure we are working on that. In the last few months, we have also started having a greater focus on our communication options. And since we are all functioning as a whole of government, I think we would also integrate, we will also combine the facilities available with the other science ministries, as well as also in DOPT. In IIPA now, for example, we set up an exclusive studio. And she happens to be the communication person there. Okay? So we could also integrate and make use of their services, because our communication is more vital compared to the other departments, because we are dealing directly with the agri sector. Similarly, our budget has gone up by about 185%. I was just calculating, it was 1281 crore. 1,281 crore in 2014 has gone up to 3,658 crore this year. And then, of course, Mission MOSAM is there. And if you talk of the Anusandhan National Research Foundation, which is also going to actually integrate with some of our endeavors, along with the new scheme where we also involve the private sector, the 1 lakh crore RDI scheme. And there also, I think it's high time, the sooner do, better would be to make people understand what is ARRF went for. I was actually telling this even to the appointed CEO, Mr. Kalyan Raman. Nowadays, I find communications letters from every ministry asking for a fund from ARRF. The Ministry of Education asking for it. The other day, Ministry of Minerals was asking for rupees 2,000 crore from ARRF. So I politely said, please, you've mistaken, this is not a banking it's not a banking cell that we have opened up, or a citizen cooperative bank. It's meant for a specific purpose. So we would also, I think that's the way, the manner, and as we start moving in that direction, people will also get used to what it is, because it's a new experience both for us as well as for them. And some of the success stories, I think we need to highlight even more. Because one day when I spoke in the parliament, and I think everybody right from the top to the bottom were not actually aware, they were quite taken aback. They were also pleasantly amused when we said that we have set up really 6 plants in Lakshadweep. I think this is one of the social media, a lot of stories to tell. There's a famous English proverb, water, water everywhere, not a water to drink. And Lakshadweep was the best personification of that. Situated all along the water and you didn't have potable water. Similar was also a situation when I was in the northeast in Cherrapunji, the heaviest rainfall, but no potable water because everything would go wasted in the flood. There we started water harvesting. Here we found another means, desalination, the first of its kind possibly, or one of the first in the world, where you could actually use the same saline water, separated, isolated from the salt, and then use it for potable. And 1.5 lakh liter per day is the amount of water. It's not a small amount. Had there been an island closer to that, you could have even supplied that. So an island which had for years and centuries suffered from this problem has not only been made water sufficient, but water rich, and also in a capacity to provide to others. And of course, the icing on the cake is the deep ocean mission, the submersible, just as Dr. Ravi Chandran was telling me that soon, next month possibly, we would be doing a Shubhashu Shukla in the earth sciences and the oceans as well. Because when 4 of our persons go into the ocean, Atlantic Ocean, as a part of the French expedition, just as he went as a part of the IS expedition, and maybe next year, when one Indian goes up into the space in the Gaganyaan, we would have 1 or more Indians going down into the ocean. So 1 up and 1 down. So, in other words, as we move on from, as we have moved on in the last 10 years from rank 10 to now rank 4 and move on to 3, 2, and 1, which is of course very inevitable. Let's not forget that this is going to be the sector which is going to add value. The huge, huge wealth lying inside our oceans, which was never explored, which was never realized. And I'm sure if you are able to actually explore, that's why I was asking the doctor, I said, you found a new species, but what are the actual properties? So she said it's biopotential. I said biopotential is a very wide term. I mean, that's the problem when you have a minister who also belongs to the same fraternity. So I said, no, we should try to identify what actually biopotential. Is it nutritional? Is it medicinal? Is it therapeutic? Is it prophylactic? But soon, of course, but I must compliment you. You made a beginning, you made a discovery, and now you'll work on it. So when we start moving ahead of these biodiversities lying below, or the bioproperties lying below, the fisheries, I think it will not even take us 2047 to carry India to rank 1. And therefore, you can have the pride of saying that India's ascent to rank 1 will be written in the 4 walls of Prithvi Bhavan. Thank you.
Thank you so much, sir. To conclude the formal proceedings, I invite Dr. Vijay Kumar, Scientist G and Program Head, Ministry of Earth Sciences, to deliver the vote of thanks.
Good afternoon, everyone. Our Honorable Minister and Chief Guest for today's function, Dr. Jitendra Singh Ji, Secretary, Ministry of Earth Sciences, Dr. Mahapatra, IMD, JS, and guest of honor, Dr. Professor Dev, respected dignitaries, esteemed colleagues, ladies and gentlemen. It is a great honor for me to deliver the vote of thanks on this special occasion, the 19th Foundation Day of our ministry. On behalf of MOES and all its institutes, I extend our deepest gratitude to everyone who made today's celebration successful. At the outset, I would like to express our deep gratitude to our chief guest, the Honorable Minister, Dr. Jitendra Singh Ji, for gracing the occasion and for launching a remarkable suite of initiatives today. Sir, thank you for your constant support and visionary leadership that continues to guide the ministry journey. Our sincere thanks also goes to our respected secretary, Dr. Ravichandran, whose direction and encouragement are a source of strength and inspiration for all of us. Thanks for his today's address that reflected our scientific pride in achievement and optimism for the future. We are also thankful to our guest of honor, Professor Dev, for his thought-provoking talk on very interesting topic, Digital Earth Initiative, focusing on AI and digital twins. Thanks and congratulations to all the institutes and authors whose reports, apps, videos has been released today by Honorable Minister. Today's launches and reports release are a testament to the hard work and dedication of scientists across MOES institutes. Thanks to Joint Secretary Dr. Sandil Pandian and his entire team for their dedicated efforts in organizing today's event. I thank all the organizing team of MOES from the GA section, protocol, offices of Secretary, FA, GS, IT team, NIC, media teams, technical staff, security and housekeeping personnel, and all staff and officials who have worked tirelessly and contributed to ensure the smooth execution of today's program. I would also like to acknowledge and thank our dignitaries, our colleagues, and participants from various institutes who have joined us both offline and online. Your presence and engagement reflect the shared commitment we all have toward the ministry's goals. Once again, thank you all for making this Foundation Day truly special. Let us continue working together with the same spirit and dedication. Thank you again. Jai Hind.
Yes, sir. I'm his niece. I'm from Kerala. They're not from the government sector. Yeah.